Okay, we're going to look at examples of the antiderivative, the integral, and how that works. And when this video is complete, you can try the homework for assignment 1. Okay, so what is a function that has a derivative of 3x squared? You can think back to how we found derivatives. Okay, the coefficient came from the exponent of the function, and the exponent was reduced by 1. So you could probably think that f of x was x cubed in order to find that f prime of x was 3x squared. Okay, a function is an antiderivative. So you're undoing the derivative of a function on an open interval I if f prime, capital F prime of x, is equal to f of x for all x in the interval. So in our first examination of what is an antiderivative, we did find that there's a family of functions. So for example, back to this f of x equals x cubed, my function could have been f of x equals x cubed plus 7. And the derivative would still be 3x squared. Or my function could have been f of x equals 3x squared minus 2. And f prime of x would still be let me fix that. I just meant to say x cubed minus 2. In which case, the derivative would still again be 3x squared. Okay, so there is an entire family of antiderivatives for each derivative. The general antiderivative of 3x squared is x cubed plus c, and c is called the constant of integration. Okay, taking a look at the integral and its result. All right, first we have the integral symbol. Remember, we looked at adding up areas. Adding up areas is sometimes, we refer to it as a sum. And this integral symbol is kind of representing the summation. Okay, f of x is our integrand. D of x tells us, or dx tells us the variable of integration. So you've seen other integrals perhaps where it's f of t dt. Okay, so we are integrating with respect to the variable t. All right, the answer to the integral is our function, the antiderivative, and we add c because of that family of functions. We could just be shifting that function up or down as indicated by these constants in the original function of f of x. And so that plus c says, okay, that graph could be shifted up or down somewhere. I don't know where it is yet, okay? Later on, we might find the value for c. All right, so let's think back to our derivatives, okay? When we're answering our antiderivative questions, finding an integral, evaluating an integral, then I want you to think of the function that has this derivative as the integrand. So what function would have 0 as a derivative? That would have to come from a constant. If f of x equals 5, f prime of x equals 0, for example. Okay, next, what function would have a derivative that is a constant? Some value other than 0. Okay, that had to come from a line. A linear function has a slope of k. So, for example, if f of x is 2x plus 1, f prime of x is 2. Okay, the power rule. We've used the power rule, for example, on that previous page when f of x is Messed it up again, but I'll do a different one. 3x to the fifth. F prime of x was 15x to the fourth. Okay? Keeping it simple, we could have just said x to the fifth, and f prime is 5x to the fourth. So if I want to undo the power rule, the coefficient, I'm going to increase, the exponent by 1, right? And I'm going to divide by the coefficient currently out in front. So here we go. The integral of x to the n is x to the n plus 1. We increase the power by 1, and we divide by that new exponent. All right, 1 over x. The integral of 1 over x is the natural log of the absolute value of x. All right, the absolute values are needed because the natural log only has a domain of x greater than 0. Okay? And so we want to make sure that whereas 1 over x has a domain of all reals except for 0. Okay? So we want to make sure that our answer is only going to take into account x greater than 0. All right, the integral of e to the x is e to the x. That was its own derivative. All right, last two, some general rules. If there's a coefficient times a function, you can bring that coefficient out in front of the integral and then take the integral just as you would in the examples 1 through 5 or in the rules 1 through 5 here, depending on what rule it was. Likewise, if you have the sum of two functions, right, we can take the integral of each piece of the function. So the integral of f of x plus or minus g of x is the same as the integral of f of x plus or minus the integral of g of x. Okay, let's look at lots of examples. You might try these on your own before you follow along with the video and see how you do. I'm sure you'll do fine. So here we go. We have the integral of x to the fifth. That would be an anti-power rule. So undoing the power rule, we're going to increase that power by 1 and put the coefficient of 1/6 out in front. That would be the same as x to the sixth divided by 6. Don't forget your plus c, because there could have been a constant for which the derivative would have been 0. Okay, x to the 37th. The integral of x to the 37th will be 1 over 38, x to the 38 plus c. The integral of x to the negative 2. Okay, the anti-power rule is going to work the same way. We're going to increase that power by 1. That's going to be x to the negative 1 divided by negative 1, which is the same as multiplying by negative 1. So negative x to the negative 1. I prefer to see this as negative 1 over x plus c. Okay, anti-power rule with fractional exponent of 1/2. We're going to increase that power by 1, call this x to the 3/2. We're going to divide by 3/2. That's the same as multiplying by 2/3 plus c. Okay, the integral of 1 over x cubed. I'm going to rewrite this as x to the negative 3rd power. We're going to anti-power rule. So that's x to the negative 2 dividing by negative 2 is the same as multiplying by negative 1/2. You could leave it as this, negative 1/2 x to the negative 2, or call it negative 1 over 2x squared plus c. The integral of the cube root of x is the same as the integral of x to the 1/3. Anti-power rule, bring that exponent up by 1, so that's x to the 4/3. Dividing by 4/3 is the same as multiplying by 3/4. Don't forget your plus c. All right, we're going to look at 9 more questions. And we have the integral of 2x squared plus 1. That is the same as the integral of 2x squared dx plus the integral of 1 dx. It is not necessary that you rewrite the integral, but it is necessary that you understand how you are just taking the integral of each piece of the sum or the difference of functions. So the integral of 2x squared will be 2/3 x cubed. The integral of 1 will be x plus c. So 2/3 x cubed plus x plus c. In h, we have the difference. Again, you do not have to rewrite this. I'll rewrite this one. The integral of 1 minus the integral of x cubed dx. Okay, integrating each piece, we're going to get x minus 1/4 x to the 4th power plus c. Letter I has lots of square roots in it. Let's rewrite those square roots as powers, rational powers. So we have x to the 1/2 minus x to the negative 1/2. Integrating each piece, we get x to the 3/2 times 2/3 minus x to the 1/2 times 2 plus c. So those coefficients, remember, are 1 divided by the new exponent. All right, J. We did not learn how to take the integral of a product. So the integral of f of x times g of x, right? Multiplying two functions together. We don't know how to do that. It's not the same as addition. So this is not true. The integral of a product is not the product of the integrals. So be careful. We have to look for another way. So what if we distribute that square root of x? So this will be x to the 5/2 plus x to the 1/2 dx. Integrating, we get x to the 7/2 times 2/7 plus x to the 3/2 times 2/3 plus c. Letter K, again, there's a product. Don't know how to do a product, so I guess I have to distribute and call this x cubed plus 2x squared plus x plus 2. Okay, then we're just doing anti-power rule. I'm going to jump ahead a little bit so I don't run out of time. Letter L, this one is very much like letter I. I would rewrite this using fractional exponents. So we have x to the 1/2 plus this 2 stays in the denominator. So this is 1/2 x to the negative 1/2 dx. Okay? All right, I'm going to skip answering that question, but I wanted to look at the rewrite so you know how to undo the derivative there. So finding the integral. Okay, what are we going to do if we have a quotient? So we have a function divided by x. Okay, remember those fractions can be broken up. So let's rewrite the fraction as x cubed over x minus x squared over x plus 1 over x. So that will be the integral of x squared minus x plus 1 over x. All right, letter N, same concept. Let's break it up. 4x to the 3rd minus 3 minus 5x to the negative 2 dx. Okay, so we're going to be taking the integral of these fractional or fractional integrands by breaking them up into different pieces. All right, last one, O. We'll look at the integral of 2x to the 1/2 minus x to the 3/2 plus 3x to the negative 1/2. Okay, good luck with those last 5 derivative integrals, and that's it for 6.1.